Hello. Hello. Good to see you all. Good morning. Good morning. Good morning, everybody. All right. Yes, here we go. Yes. Good morning, Vicky, twice. Good morning for the avatar and good morning for the text. And good morning, Vincent, for the animated avatar. Good morning, Vanita, for Mariam, Jocelyn. Mariam, that is an interesting. That almost looks like. Anyway, okay. Good morning, and then good morning. Jocelyn twice, Mariam twice, Vanita. Oh, interesting. What does this say? That the people, when you're in it to win it. Good morning. So who else did I not say? Right. So good morning, Vicky, Jocelyn, Mariam, Vanita, Jean. Good morning. Good morning, Vincent. I think I said good morning, Amelia. Oh, Amelia. Great question. If I don't remember to answer or address your question today in class, remind me. I'm not to call you out singly, but and you, if there's any way for us to get you more points for that question you sent, let's do it.
Okay, thank you.
Oh, thank you. Great. So you know what I'm talking. Okay, great, great. Yes,
Yeah.
awesome. And then you just got points for voice. So and for for closing a conversational loop. So perfect. Okay. No, definitely deserved because yes, great, great. So we're going to start in a second, everybody. And I'm not trying to single people out, but I do love one thing I just want to appreciate to all of you is it's not always the same people in this group, and that's really great. Like I feel like different things are bringing out different people in different ways or different times. I'm getting to know, many of you at which is great. And we still have some time in this semester and hopefully time together next semester, many of us. So I really appreciate that. I appreciate the multiplicity of, oh, okay, I'm looking in the chat. I'm sorry. Oh, did I say good morning, Melanie? Good morning, Melanie. I'm so, and Mel and Melanie, same thing. You had a question, I believe. You also sent me a question that I would like to address today. You can remind me of it later. I might be confusing two things, but I definitely know you sent me a question. Okay, hold on. I'm looking in the chat. Yeah, yeah. Okay. Um, oh, you know what it is also, to be super honest. Oh, wait, when will grades be up? Oh, you mean from the midterm? Okay. Um, yes, please. Okay. We're going to start in a second, but certainly I understand grade anxiety and I apologize. Um, let me address a couple of things. So there's things happening in the direct chat. Number one, right. I still don't have your exams, and that is making you nervous, I'm sure, and I do apologize for that. Wait, more people coming also. Um, I'm going to try to finish them during the holiday, during all of our holidays. I mean, it will be tricky because I'll be with family as well, but I have another treatment but I'm going to try my best because I know it's making you nervous and it's not fair, or it's certainly not good, that you don't have your exams back. So I will do my best. But I can also tell you, oh, no, thank you. Well, thank you. Okay, so people are sending me, but I appreciate the honesty of some people in the direct chat who are admitting that they're getting nervous about the situation. Totally fair. And I'm here to tell you also, like, like, I mean, we're all nervous. I can't tell you not to be nervous. It's totally fair to be nervous. Um, I can tell you, I know who is in the direct chat asking, and I, the simplest thing I can say, well, I want to tell the person who's saying I'm getting nervous. I know you well enough and I know your work well enough that I can tell you it's going to work out better than you think. I mean, I'm telling you all that. I mean, anybody who's nervous and who's paying attention right now, if you keep with me, you keep doing what you're doing, and you keep turning things in, like even if the exam grade turns out to be less good than you're hoping, which is possible, um, in the course and the end of the day, is those of you who are still with me and still submitting things and staying caught up and trying your best, and those of you who are being honest and submitted an honest, thorough exam, your grade in the class will work out better than you think. It will. I, Let me slow this down. That doesn't mean everybody's getting an A in this class. Okay, I'm not guaranteeing that anybody's necessarily like I can't guarantee any of you until I see the exams that you're getting an A. I'm not saying that. But I am saying a couple of things. I'm saying, and this is to everybody, okay? Well, no, first of all, I'm saying to the person who's specifically asking me that in direct chat, I know your work well enough already at this point, and I know how hard you're trying, specific person, that I am telling you, you're definitely not failing this class. I mean, I don't know what failing means, different things to different people, but I'm telling the person who, well, I should just write it in direct chat. Actually, hold on one second. But then I have a speech for everybody. Hold on. I should just do that. One second. I'm sorry. But it's fair to be worried about this. So hang on one second. One second. One second. Okay. What I'm doing right now, this is for every pardon, because I know it's that time of year, and I know I'm not helping anybody by not giving these back yet. So hold on. I'm reminding everybody in the chat, I mean, in the everyone chat, that's my cell phone number. If you are particularly concerned, like if you're like, wait, but I just don't know, I just need to know, like what's going on with me in the class, send me a text. We'll set up at the very least, we'll send up a brief time to talk on the phone. Where it doesn't mean I can magically make your midterm finished yet. I mean, I'm working as hard as I can. Like I will try, but even if I don't have that exact information for you, we'll talk on the phone about your general situation. I'll talk about how the general grading works, and we'll look at your general situation, and I'll try to give you more of a sense of where you are, in general. And I'm telling everybody right now, if you're like listening to me right now, it's like you're still here in the room and still sort of on top of your work, that means a lot more in this class than you think. And I'll be more specific in a moment. But I can't get, it's not about that everybody's going to get an A, but it is about this. Number one, everybody could get an A. You need to remember that I don't have a limit on how many A's will be given out. That's like important to remember. Number two, okay, well, will some people get B's? Yes. And I know some of you don't even like getting B's. Some of you, well, partly I want to say you want to get used to some B's as a science major, but okay, are some of you going to get B's? Yes. But as far as passing or failing, some people, again, the reason when you end up with an A or a B or something like that in this class or some version, right? You should not look at it as a gift or not look at it as you just automatically got it, because it isn't automatic. Because yes, there are people in the room. There are people on the roster who will get C minuses or D or Fs or whatever, the things that you really don't want, right? But I'm here to tell you that most of the people that will get the grades that you're really worried about, or that would really stop you from moving on in the major, or have you retake a class or something like that, mostly those are going to happen with the people that are not really they're not really here as part of this discussion, right? Or sort of already know that they're in that situation and are not even asking me. They don't even for their midterm back. Honestly. And maybe some of you are who happen to be right now are even in that situation. What I'm telling you here is your first job is to do all the work, right? And you still have time to do all the work. If you feel like you're doing all the work and you hand it in your midterm on time, and you're at that, right? And it was thorough and all that. If you're at that level, whether you're okay, I've done my job, what's going on? Then you should really text me and set up a phone appointment, because I will explain to you again how if you're in that situation, if you're doing everything you're supposed to, you're not going to fail. Whatever failing means, Like, unless failing to you means a B, but then we'll look at that honestly and see, is it possible you're going to get a B? Like, maybe, because like maybe physics is still a struggle for you, blah, 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 blah. But I know I'm making this too complicated sounding. I'm saying the whole grading system is designed so that if you stay with me and do your part, you can't, no matter how hard physics feels or seems, you can't actually fail this class if you hold up your end of the bargain. There's enough people who will fail it or whatever because they couldn't hold up their side of the bargain. And by the way, that might be for super legitimate reasons. It might be for health, mental health, family. I know all of this. It's happened to me and my family. So even there, let me also say, if it happens that you have to redo this class, there is no shame and no judgment. I had to redo classes in my life. Sometimes it just works much better the second time. Like, so let me also say that if I end up seeing you in this class again, no shame, no judgment. We both just work harder to make it work so that you can move on in your life. I promise you that. And some people just need to hear this twice. I was one of those people sometimes. Um, but now, and I'll move on in a second, but I really do want to reassure you all, and congratulate you for staying with me for this long, especially if you have anxiety that you don't know what you got in your midterm yet. So the other thing is someone put in the chat, like, is it still possible to hand in game portals for those points? Especially if you are a participant in this class, is it still possible to get the participation points, which do matter a lot? The answer is yes. The answer is yes to that direct chat. But let me just be clear about that. What you want to do, what any of you want to do who are concerned about grades right now, what you want to do is first, well, really, what you want to do is look at any and all of those portals that are technically due in December. And like, don't look at the game turn one, turn two, turn three. Those are each worth 5 points. Honestly, those are like weirdly the one thing in the class that are meant to be a spontaneous daily reflection. They're worth 5 points if you do them on time. If you do them like a day late, they're worth 3 points. After that, it's not worth going back to all those game turn one, turn two. That's not worth it to you or to me. And it defeats the purpose. But all the other portals, the ones that are like show avatar, show video, speak, you like use your voice, all of those other ones, yes, you can still totally do them. And some of them you can do them multiple times. A lot of them you can use more. Like there are people in this room who like show video every day, and like every day they upload like a screenshot of their video. Like now it may you can't like retro a ton of them, but there's still there is time to use all of those non-turn portals for any. So just look through them. You'll see things that apply to you. And yes, you can. So I don't know if that's, wait. So I'm looking in the chat. I hope that's sort of. Okay, wait, I'm looking in the chat. Sorry. Okay, hold on. I'm just, uh, hold on. And I know someone's in the waiting room. Sorry. Um, uh, so a lot of things are happening in the chat. Just bear with me for a second, sir. Okay. Oh, I'm messing this up. Hold on. Okay. I'm going to shift gears in a second. Okay. There was another question in the direct chat. I'm saying, so maybe look, and my grading system is confusing. My grading system is unusual. It is confusing. It is not meant to be confusing, but it's complicated enough that it is confusing. Let me slow down for a second. The First of all, once you get used to the grading system, and you're not alone if it still confuses you. Please remember that if you have me for 204, it'll be the exact same thing again. So it's like kind of worth learning now. And many of you will find, even if you don't totally get the grading system, if you kind of trust me a little bit, for most of you, your grade at the end of the semester is going to work out a little bit better than you might be thinking right now, especially if you work hard and get nervous, but you don't rock exams. Like, I understand that really. And the grading system is like designed for you. It's not very clear, maybe. So I'll repeat it aspects of it again in a moment, or if you make a phone appointment with me, I'll like explain it on the phone again. And I'm saying phone now anyway. So first of all, one thing about the grading system, someone just asked in the direct chat. I am saying yes, I will still accept. First of all, I'll definitely still accept old homeworks. I will. If they're super old, will you get all the points on them? Maybe not. Probably not. But you'll get a ton of points. It'll be worth it. If you okay, yeah, I will still accept backed homeworks, and I certainly will accept revisions on homeworks. I mean, anything that was turned in on time, that means it can get all the points. You certainly can turn in revisions on all the homework and get all the points. That's for everybody, no matter what your situation is. Now, also on the game portals, I'm saying yes, I will still accept game portals happily. But there's two types of game portals you might have noticed. There's one that's just like every time we have class, like for class one, we had turn one. For class 17, we had turn 17. Each one of those is just like the quick 5 points exchange where you just like say, I said hello today, or I asked a question today, whatever. Those I'm saying, don't go back and do those. That's the only thing I'm saying in this class. We're up to like turn like 19 or something now. Like we're up to like the 19th class or something. It is not, doesn't make sense for you to go back and turn in like for class number 3, I said hello. That defeats the purpose. Don't do that, I'm saying. But I'm saying anything else, like all the portals that say, I showed video, or I showed an avatar, or I consulted the YouTube channel, or like I know they all have silly names. So you kind of have to you have to open them up and like read what they mean if you've never looked at them before. But and how do you know the difference? I'm saying all the portals that don't have a due date of like 11:59 tonight, or what, all the ones that are due December something, that's on purpose because it's trying to tell you could do those anytime. No, wait. Oh, okay. You got it. Okay, great, 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 great. So, for example, the person who just understood, who's asking this in direct chat and just got it, which is great. So, there's a portal called Closing a Conversational Path. It's a silly, confusing name. I apologize. It's meant to be cute. But that's a portal for you, person who's in direct chat right now, who just asked a question and then just said, "Oh, okay, I got it." Like open up that portal like when you want to that says closing a conversational path and just put in there. Like you can screenshot this direct chat that you just did, or just remind me, like I asked a question about the submission of the portals. You explain it. I got it. Like, and then you get the points for that. If anybody else wants to ask me about this, like it's not too late. And I know I sound like all intense because I always sound all intense. I'm saying all this to try to help you guys have a little less stress in your life in this class. I know it's ironic that the louder I scream, calm down. Like, how is that supposed to calm anybody down? I know. And the more I talk about grades, the more it freaks people out in a way. So I'm going to move on in a moment. But I'm really here to say that the grading system is designed so that you have a huge amount of credit in your final average for the ways in which you try to participate and try to work and try to do homework. It's designed so that if you really keep doing stuff, as many of you do, then you have a lot of credit cushion in your grade so that just in case, quark forbid, you struggled on exams, which most of us do in physics. Most of us do. If your exam grades don't look amazing, there's still a lot of buffer in your grade to make the grade higher than what your exam grades look like. And that is not a gift. That is not charity. That is not a lie. That is saying there's more than one ways to be a student, and taking exams is only one of them. Okay. So again, I'm just going to say before I move on, you could keep asking questions. If you have specific questions, you totally can keep them in chat. But I'm trying to say to everybody, if your big concern in life is I'm doing everything he says and I'm trying really hard and I'm turning things in, but I find this class confusing, and I'm worried, I don't know what my grade is, but I'm doing everything and I just need to, then I get it. I'm with you. And that is my fault, partly for like not being finished with the midterms, or it's entirely my fault. But I am here to say if you're in that category where you're doing everything, but you want to know what the outcomes are, at least send me a text. We'll make a phone appointment. I'll talk to you about your specific situation more specifically, and I will reassure you. And and um and if there's a real jam, if they're the people that really just aren't doing anything or like really are in trouble, like either they know it or they're going to hear from me or they're not even part of this conversation now because they've checked out a long time ago. Like, and I don't mean that as an insult. I mean, it could be for very legitimate reasons. But if you're at that place where you're feeling like you're living at razor's edge with this class, you're probably in a lot less trouble than you think. That's really the best. You're probably doing a lot better than you think. That's the best thing I can say for the moment to all of you. But I mean it. Okay. 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 So I hope that's okay. Okay. So I'm gonna go on with physics now, but now, sort of physics. But please do. I mean, does that sort of make yeah, I mean, please put in the direct chat, any of you. Look, if one of you is like looking for points right now, just put in the direct chat. Either like, we got it, like move on, or like, yeah, but I still don't. Like if you put anything in direct chat, like like, just let me, I'm going to move on unless I hear from someone like, yeah, no, we're still, I don't know, but got it. All right, thank you. Oh, and that was in the public chat. Great. So that's points right there for closing a conversational path. That's all, like you put that in the portal. That is all. That's points. Awesome. Thank you. Okay. Oh, oh, you did. I'm sorry. Sorry, Andy. Okay. Thank you. Oh, that's what that is. Oh, okay. Sorry, I didn't catch that. And put that in the portal that says, please move on or please go forward or something to speed up. Okay. And now go back. All right. Got it. All right. I'm moving on. Oh, and there's Hudson. Thank you. Got it. Loud and clear. The great set. Right. No, and Hudson, that's like at least two portals that you can go and write. Oh, three, because you're on video. Totally get it. Totally appreciate it. So thank you. Okay. Okay. Now, what am I going to talk about now? Well, it's funny. It's funny. But actually, it's too steep. Like last week, we were talking about the lab situation. Another place where I could. Oh my God. We were talking about the lab situation, and in some sense, in theory, I finished the discussion, but it was a little bit quick at the end. Um. And then I had you watch a couple videos. Oh, wait, and I'm sorry. Wait, I'm sorry. There was another question in the direct chat. Sorry, I just realized. Someone asked in the direct chat, what's going on Wednesday? I believe, yeah. Someone said, what's going to happen for class on Wednesday? I believe this Wednesday, the day before Thanksgiving, I believe that's a Friday at John Jay. Tell me if I'm wrong, but I believe, so there's nothing this Wednesday. Like, as far as John Jay is concerned, it's Friday. So we're just like off from this class. Tell me if that's wrong, but I believe that's correct. Um, um, Now, what I also believe, oh, and also tell me, I'm sorry, tell me also in the direct chat, and maybe it could even be someone who hasn't said anything yet. In the direct, remind me, have you handed in your formal report on Lab 5 yet? Or I still want to wrap up some comments that I was making on it, but if you've already turned it in, I'll make them quicker than have you turned in your, report on Lab 5? No. Oh, thank you, direct chat. Not yet. Okay, those of you who just went in the direct chat, please submit for points for that. I'll give you. There's a portal called For Right or For Wrong, which means if you answered anything that could get that counts. So that's points right there. Thank you. Okay, so I want to address some things about the lab. And the interesting thing, I mean, I want to finish. I was trying to help you with the lab. Um, but now I want to finish addressing things about the lab. But the good news is that when I wasn't here Wednesday and I asked you to watch a couple of videos and I asked you for comments about those videos or questions about those videos, I got some really awesome, like I asked you, tell me something that you now understand, tell me something you don't understand. And I got some feedback from some of you that was super helpful. And what you guys told me that you didn't understand, again, it might have made you nervous that you didn't understand the following, but it made me really like, oh wow, they understand a lot more than they think if they could even ask that question. Um, and it's really helpful to all of us. So I want to spend some time right now addressing some of the questions that I already got from you about inclined planes, about friction, about this lab. I'm going to address what I remember, but today we still have time. You can put anything in the chat, especially if it will help you get a better grade on your formal report for Lab 5. Like this is still the day for that. So don't be shy about the chat. I will start by telling you that in the lab, like what conclusions that we found last week that are big conclusions in the lab. Now, these are conclusions. Obviously, the explanation for it was like last class. You have to go back and watch that video. But I believe that according to all the diagrams, and obviously you have to write a lot more about this in your lab, but I believe according to all the diagrams and calculations and everything we analyzed last week, we come to the conclusion that when the marble is traveling up the plane, the magnitude of its acceleration can be found by what I just wrote here. A equals g sine theta plus mu times g cosine theta. And when it's going down the plane, it's all the same terms, but there's a minus sign instead of a plus sign. That's really important. First of all, again, just going back to last week, like even before you put any numbers in, even well, okay. Even before you put any numbers in, Okay. First of all, just to summarize what I just wrote here, I'm just summarizing the logic of what you're supposed to turn in for the lab, the logic you're supposed to understand, the surprising fact that the ball takes less time to go up than it does to come down, right? Which is a surprise, but it is the result of the data you collect in the lab. If you collect it carefully and you set everything up carefully, you find, despite expectations, that the ball takes less time to go up than it does to come down. The reason for this, after you draw all the diagrams and you do all the F net equals MA and everything, the reason that the time is less on the way up is that, in fact, the acceleration magnitude, the value of the acceleration is actually greater on the way up. The acceleration is greater on the way up. Therefore, the average velocity is greater on the way up. And therefore, so the ball's faster on the way. Wait. Yes. Okay, good. Now I just see something in the direct chat. Oh, great. Okay, so two things in the chat. Thank you for the person that texted me. So that's good. That's what I wanted. And I just forget. So after all my classes and stuff, I'll text you back and we'll make an appointment. Great. And then someone else is saying in the direct chat about two different forces working against it, going up then down. Okay. That's the analogy. Yes. I am saying the ball is actually going faster on the way up. Why? Because it's actually accelerating at a greater rate on the way up. Yes. Now, why is that? Because of that plus sign, and what, as opposed to a minus sign. The plus sign means exactly what someone just said in the chat, that two forces are working together when the ball is going on the way up, whereas on the way down, the forces are in conflict. Now, here's the confusing thing. This is partly related to a question that I want to address all the questions people ask me, in Google Classroom. One thing that confuses people all the time, that at least confused one person, is I know that on the way up, the forces seem to be working against the motion of the ball. That is true. Like the ball is going up, but both the forces are pointing down. So it seems like that's a big problem. It seems like, wait, all the forces are working against the ball. So isn't the ball like totally being impeded? Isn't the ball being blocked? Shouldn't the ball be going very slow since all the forces are against it? Now let's be very careful. I mean, I get that, but it's actually not right, because, well, yes, the balls are working against the motion of the ball. Yes, the forces are going like this, like are pushing down, while the ball's velocity is pointing up. Okay, so what does that mean? Wait. Well, that's interesting too. Wait, sorry, I don't want to get my. Someone's also asking, does the shape of the object matter? Wait, sorry, lots of things are happening. Um, wait. Okay, let me. This is great. Like everybody's in the chat. This is awesome. It's like a class. I love it. One thing in the chat is, does the shape of the object affect? Yes. Yes and no. The shape of the object will affect the numbers. If the object were flat and sliding, certainly the effect of friction, the mu, would be a lot greater without a doubt. But so it would affect the numbers. But this larger point that I'm making right now, it would not change. In fact, honestly, if there was more friction, the larger point that I'm making would be more dramatic. Yes. So I don't know. So what it is what Annie's saying in the public chat. Like, yes, that is a good understanding, anyway. Right. So here's the thing, and this is now going to address like two questions that people are asking. On the way up, the ball's velocity, yes, is pointing up, whereas all the forces and therefore the acceleration is pointing down. So what that means is, what confuses people is that on the way up, the acceleration, the change in velocity, is a slowdown. Like the ball is, wait. Okay, slow down for a second. It's sort of, yes, direct chat person. Like what this means is, on the way up, acceleration, remember, in general, acceleration means change in velocity of any kind. Could be a speed up or a slowdown. It's all called acceleration. It's all a matter of the plus and minus signs. So on the way up, the acceleration, the rate of acceleration is the rate at which this ball is losing speed. On the way up, it's losing speed. And yes, as someone just put up in the direct chat in a way, on the way up, when's the ball going to be done with its journey on the way up? When's it going to get there? When's it going to get to its goal? Well, where's there? There's no particular place it's trying to go. It's just going until it gets to a resting state, as someone just put in the direct chat. It's just going until it runs out of speed. Right? And then it'll start coming down again. So what the acceleration is doing, even though everything looks like it's working against the ball on the way up, if you think of the ball's job as running, as if you think of the ball's goal as to run out of speed, everything is helping it run out of speed. Everything is sucking speed out of the ball. They're all working together. When I say all, I mean gravity and friction are both working together to suck speed out of this ball to bring it to rest. So it comes to rest very quickly. That, oh, great. I see some affirmation in the direct type. Great. No, I'm seriously excited, and I look upset, but that's just because I'm bald. No, I'm very excited, and I do think this is hard. No, great. Okay, so yes, on the way up, all the forces are working together to slow down the ball, so it loses speed at an incredibly rapid rate. And it goes from some initial speed, whatever, 25 meters per second, all the way to zero. And so its average speed is like 12 and a half, whatever. And that's really fast speed. And so it does it in a really short amount of time. Then on the way back down, there's this minus sign. Like it's all the same numbers, all the same effects. Like friction doesn't change itself or anything, but it flips sign. On the way back down, friction always opposes your motion, right? It was on the way up, it was going against you on the way up. Now you're coming down, it's still going against you. But gravity does not flip. Gravity is always pulling down. So gravity's still pointing down, whereas now friction's pointing up when you're going down, right? So now the forces are in conflict with each other. They're in conflict with each other. And are they in conflict with your goal? Well, they're not in conflict with your goal, but they're not helping your goal a lot, because now you're on your way back down. Now on the way back down, you're gaining speed. You are, otherwise you wouldn't be. Now your acceleration is a gain. So now you're trying to get back down if you're the marble, and you're building up speed as you go back down. But you started from zero now, like you started at the top. So you're building back speed, but you're done. The experiment's over as soon as you get back to the place that you originally started, right? You're not trying to, now you got a sort of normal situation where you're gaining back speed until you're at the bottom again. Well, the rate at which you're gaining that speed is not as high as the rate at which you were losing speed before, because now it's a minus sign rather than a plus sign. So like before, the two numbers were like 5 and 3. I'm just saying, if like g sine theta was 5 and mu g cosine theta was 3, then on the way up, the total is 8. You're like losing 8 meters per second every second. On the way back down, it's 5 minus 3. It's the same numbers, it's just a subtraction now. So it's 5 minus 3. So what does that mean? It means you were losing 8 meters per second every second on the way up. So boom, you ran out, you got to 0. Now you're just gaining back 2 every second. So by the time you get back to the bottom, you have not gained back all that you ever started with. The bottom line is, I'm just making up numbers so you can like get a perspective on this. Like if the ball started off with whatever 25 meters per second of speed, then it goes 25 to 0, and then from 0, so it goes 25 to 0 really quickly, and then 0, it dribbles back down to 25, gaining. By the time it gets to the bottom, it doesn't have all the 25 back anymore. It has like 18 or something. I'm just making up numbers. So on average, on the way up, it was going 12 and a half meters per second. On the way back down, on average, it's going like 9 meters per second. It's slower on average on the way back down because it never gains back all that it started with. I'll say it one last time, and then we're going to look. The rate at which the ball loses speed on the way up is greater than the rate at which it gains it back down on the way down. And the reason for that, 100%, is that all the forces acting are always the same in magnitude, but friction flips its direction, whereas gravity never does. So the mere fact that on the way up, gravity and friction are working together to suck speed out of you. Whereas on the way down, gravity and friction are in conflict to give you back speed. That's all the difference in the world. It all comes down to that plus sign versus that minus sign. And that plus sign versus that minus sign all comes down to the fact that friction flips direction, whereas gravity never does. That's, wait, yes. So it's going to be slower going down because of that. Yes. 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 I'm just looking at the right side. I think if we're saying the same thing, yes. Now that's English. Like you, and that's your job, like in the lab report, to express that you understand this. Or if I ask something like this on the final exam, it's like you're trying to conceptually understand why, even though we didn't expect it, it actually makes sense that the thing would go slower on the way back down than on the way back up. Bottom line, well, no bottom line. The bottom line I just already said. But then, of course, now how do you get to that English? You have to draw a bunch of pictures, which we did last week, and turn all the pictures into F net equals MA on each axis, which we did last week. So, and then F net equals MA, you divide both sides by M, so you get these A statements. Like, don't memorize these. They're not like laws. They're just the results for this particular situation. So you have to be comfortable with all the math and the diagrams and all that to make all this complete. And you could still keep questions in the chat and stuff like that. One sec. Okay. Oh, wait. Good question in the chat. Just a quick stop, or someone just asked in the chat. And again, all the stuff in the chat is great because if nothing else, it shows me that we're in a class together. So someone just said in the direct chat, will we ever get to a point in physics where we need to memorize entire equations? I mean, the most blunt, honest, fast thing I can say about that is no. Like no. I mean, no. Um, I have a lot more I could say about that, but like as far as these physics classes are concerned, by the time you get to an exam, first of all, the equations are given in the front page of the exam, and you're allowed to go all over the web and all that stuff. So, but the reason for that is the farther you go in physics, the more no one in physics actually tries to memorize equations. I know a lot of the equations because I use them all the time and they make sense to me, but I don't sit down and memorize them. Like, anyway, so no, the answer is no. For good or for bad, you don't. Yeah. Well, that's more of an, okay, wait, I'm going to move on in a second, but that same person in the direct chat then said, because I forget which ones to use when. That's more of an issue for everybody. That's a very honest thing to say. The issue in physics is which equations to use when. So that's what, but that comes with practice. Like that's why we have all of these. That's why you can't learn physics in a day. All of these classes are about trying to show you the logic and practice about which to use when. That comes with, that's not a joke. That's hard. And that's also why I'm very sympathetic. Like that's what I'm here to teach you, but it doesn't come overnight. So that's why you get a lot of credit for trying, if that makes sense. But yes, that's the hard part. Right. Yeah, no, fair enough. I'm going to move on and we'll talk about this on the phone or whatever, but yes, fair enough. Um Again, just please remember everybody, like I love this stuff. I signed up for this job for this stuff and to some extent I'm here to try to make it as easy as possible to show you that it's simpler than it looks or easier than it looks, but really any of it that I can make look easier, and it always looks easier when I'm talking about it than when someone's doing it. I know that. But please always remember, if I can make it even look at all simple or straightforward, it's because I've done it over and over and over and over and over again, 3 times a day for 40 years if you count on, I mean, I've been teaching it for more than 30 years. That's a way to learn it. And then before that, of course, I was studying it for years. It comes with time. That's why I have to be, none of this made sense to me at the first time, really. But anyway, so anyway, uh, uh, so this great question came. Good. Okay, good. This great question came. Well, actually, a couple of versions of this question came. Ha! Okay, that's very funny. No, all right, that's very you definitely should be a portal for that. No, honestly, no joke. I've been teaching for more than 30 years. And if you count when I started studying, that's for real. So thank you. And I'm not bringing that up to like flex. I mean, I sort of like I'm proud of the fact that but by the way, you know why I've been doing this for more than 30 years? Do you know why? Because I love it. I hope you can tell that. And that's my biggest advice to all of you is you find something that you love and then you'll go deep with it. Don't try to do something that you think someone else needs you to do or that you think will lead to a lot of money because it won't unless you love it. Like seriously. But anyway, yes, I've been teaching for over 30 years. I started college in 1988. So since I was a physics major in college, so I've been looking at physics, whatever, since about that long. But did I start? Yeah, I started college in 1988. Yeah. Okay. So thank you for the compliment. Um, so this great question came. And again, I'm not frustrated. I'm just exhausted. Sorry. This great question came in the portals about plus and minus signs. Okay, so now it's okay because there's now after you do all this conceptual stuff, you got to plug in numbers. It's a lab. You got to plug in numbers, and first of all, you actually have to show with all this A, G stuff. You have to plug in numbers and like show what the times actually are. So that involves other equations too. Make no mistake. You've got to convert. You get accelerations from these equations, but then you got to use other equations from the beginning of the semester to solve for average velocities and then for times, right? And we can go back and review that at some point if you want. But there's like a lot of computations in this lab. But also, let's be clear, you don't have mu when you're doing all of this stuff, right? So what I just explained about A is the logic of why the A's are different in the way that they're different. And so you logically show why the times are going to be different. But then, you then have to plug in your A's in order to solve for mu. And at least two people wrote me like when they then went to plug in their A's, and G and angle and all that, like they got a negative mu. So I'm going to slow this down again. I know we still have time. At least two people, maybe one of them was from a different section, but at least two people wrote, wait, I thought I understood all this, but then I plugged in 9.81 for G, which you should do. And I plugged in my angle, which I got by measuring, with rulers or protractor. And I plugged in my angle and it was the same angle all the time. And it was the same 9.8 all the time. And I plugged in the A that I actually got from taking my stopwatch and kinematics and all that. But then when I plugged in and solved for mu, I got a negative value. So what does that mean? Or, I mean, am I doing something wrong or what? Okay. Thank you. Okay. So first of all, that's a great question. For real, that's a great question. Not only does it show you're doing a bunch of stuff, but the fact that you would even notice that it doesn't sound like it makes sense that mu is negative, you are very correct to notice that. And yes, a real physicist, a physicist would stop and go, whoa, just because the number, this is where physics is different from math. We're not just doing math blindly. We're trying to make sense of it. So at the end of the day, if you get a mu that is negative, yes, something is wrong. You're correct. And good for you for noticing that. Now, I'm here to tell you a couple of suggestions of what I think probably happened but you have to correct something. And at the very least, let's say if this happens in an existence, I know I'm not the one grading your lab reports, but I eventually grade your exams. So say something like that happened in an exam and you're all stressed out and you're running out of time. At the very least, what you would do in the exam, even if you can't fix it, you would write a paragraph saying, but here's the thing, I got this negative value from you. I know that can't be right. and I'm looking over here, looking there, but I'm running out of time. Like, I don't know how to correct it, but I know something must be wrong. Here's my conjecture. You'd get points for that on an exam. Again, it's all about authenticity, honesty, thoroughness, showing your mind. So just as a sidebar, that's why I get excited when people send me questions like that. It shows you're thinking like a physicist. So can I give you all the points if you don't have a perfect mu on an exam? No, I can't give you all the points, but I can give you a ton. If you even say something is wrong, if there's a negative mu, I understand mu well enough to know. All right, so what happened in the lab if you got a negative mu? Well, my first thing is to most of you is remember, well, I'll write it down. If you did this lab the way we are strategically recommending, and if you analyze the lab the way we're strategically recommending, the whole reason that you broke mg up into mg sine theta and cosine theta, rather than breaking up the reason you took a vertical line and broke it into two components, which I know was what half the video like that I asked you to watch was about, and half the confusion of this lab is about the reason you broke up mg. Well, right. The reason you broke up MG is because MG does not lie, like someone just said in the direct chat, does not lie on the x-axis or the y-axis. That's correct. Assuming we chose an x-axis to line up with acceleration, which we don't have to, but we strategically do if we want to make, I mean, if you think this thing is hard enough, well, the point of the second video that you watched was to show that if you think this is hard, and it is hard, it's even harder if we don't follow this strategy. Like, that's really the point of the second video, and we'll get back to that. But as hard as it is to break up MG, we do it because it's even harder not to. When we break up MG, we are choosing to line up the positive x-axis with the direction of expected acceleration. Now, this means, that I think a lot of you get, like in other words, we tilted our head. We made the x-axis be the direction of the ramp. But I think a lot of you are getting that more and more. The thing that you might not recognize as important is that it's not even just about the general like shape of the x-axis. It's also about positive and negative signs. We're literally saying we expect the ball to accelerate down the ramp. We expect the ball to accelerate down the ramp, no matter whether it's moving up or moving down. I'm going to say that again in a moment, but we expect, no matter which way the ball is moving, that it is accelerating down. What do I mean by that? I mean the same thing, like from the beginning of the semester. If I throw something up, oh, you can't see, but if I throw something up, straight up, and it comes straight down, remember, either way, it's accelerating down. How do I know? Because on the way up, it loses speed. On the way down, it gains speed, right? So gravity's always, right? So like the 9.8 number, it's down either way. Same thing on the ramp. The ball is accelerating down, whether it's velocitizing down or not. Now, why do I care? Who cares? Excuse me. Now, do you believe that I've been teaching for 30 years? No, okay. Now do you believe I'm that old? The ball is, thank you. The ball is accelerating down no matter what. So what that means is, here's the point. Here's the point. That means I'm calling the down direction positive, no matter what, in the whole lab. I'm calling the down direction positive. Let me, and I bet a lot of you didn't do that, honestly, or you think you did, but you didn't. I mean, so let me be clear about it. This is a very common confusion. Either trip, both trips. The down direction is like down the plane, I mean, down the ramp is positive no matter what. Now, what does that mean? First of all, it means every time you plug in 9.8 anywhere, you're plugging in 9.8. You're not plugging in negative 9.8. In fact, I should really be clear about that and say for the final and stuff like that. Oh, that's my hand. No matter what. Oh, wait, is that my hand or is that somebody's hand? Wait a minute. Does somebody have a question? No, it's my hand. That's so weird. Okay, sorry. Um, no matter, first of all, G is the number 9.8. Always, from now on, in all forces and everything, whenever you're plugging it, it's just the number 9.8 or 9.81 or 10 if you're rounding. But you shouldn't round in a lab. You should round on exams, but not in a lab. Um, so the number is 9.8, not negative 9.8. That's number one. And that some of you might have made that mistake. But number two, when you plug it, when you're solving for mu, all your 9.8s are positive numbers, should be. All your thetas should be positive numbers, like first quadrant, like low, small angles. Then you take cosines or sines, you're going to get positive numbers for all the sines and cosines, right? And your A, I'm talking now to those of you who are like plugging in numbers in order to solve. Oh, good. Okay. In order to solve for mu, let's get it straight. Even what you're plugging in for A on the left side of this, I mean of this of this, what you're plugging in for A is a positive number in both cases. Whether the thing is going up or going down, it's a positive number because the acceleration is pointing down the plane. And if you plug in all positive numbers, as I'm recommending, first of all, then when you solve for mu, either one of those equations, uh, yeah, well, both of them. Like you like it's two different A's, right? It's A for up and it's A for down, two different A's, and you'll get and it's and one takes a plus sign and one takes a minus sign. So it's almost a check. If you plug in all positive numbers there and then rearrange to get mu, sorry. Right. If you so I'm looking at the top one. You could do both to get you the same answer. But if you look at the top one first, when you rearrange to solve for mu, all of those numbers that you're plugging in should be positive numbers. And your A on the way up, your A magnitude should be very so a high number and subtracting from it a low number, G sine theta, and dividing it all by G cosine theta. Like, first of all, if you look at it, you have acceleration units in the top, you have acceleration units in the bottom, the meters per second squared. In other words, all those units should cancel and you should get a fraction that has no units at all. But specifically, I'm saying your A up number should be a lot higher than your A down number. And I mean literally higher because all of these are positives if you're doing it the way I'm recommending. And so then when you plug in the numbers for A up, it's a subtraction in the denominator and that should work out fine because the A up number is very large. Like it's large enough to be larger than the G sine theta. So when you subtract, you get a positive number. And then similarly with the other equation, you could check again, you'll get A down plus G sine theta in the numerator, but the A down is a much smaller number and it should work out to be the same number for mu. So definitely, we have 15 minutes. So first of all, it's a great question about the mu being, but it really should be positive if you make everything positive, and you should make everything positive if you're really doing this the way we're talking about. So just anybody, just raise your hand or do something. Just does that make, even if it wasn't your question originally, does that make any sense? I mean, one person did tell me that in the chat, but okay, okay, good enough. Thank you. Okay. Oh, and then that's more. Oh, thank you for the thumbs up. Oh, Annie, thank you. Okay, and direct chat person, thank you. Okay, all right. Now I wanted. There's another question in the direct. Well, so that was one big thing in the direct chat. There was another. I mean, not in the direct chat. I mean, in the in the portals from last week. There was another question. This one I'll answer sort of more quickly because I know I've been talking so much. Someone else said, and let me back up also say those two videos that you watched. Okay, so one of the video was this huge analysis of mg sine theta, breaking up mg into sine and cosine. Hopefully that helped a lot of people. But to be clear, that whole and then it made a big comparison about what happens if you break up mg the way we're doing it here, which seems hard at first and seems weird. But then it went the other way and said, well, what if we don't do it that way? What if we do it this way that seems more sensible? It's trying to show that the way that seems more sensible ends up leading to a lot more work. And for the record, you are responsible for that material. Like I often do, the final often does have a lot to do with that. So you're welcome to continue asking questions about it and stuff. But two aspects of it that confuse people. One is that video that compared breaking up mg versus not breaking up mg and instead breaking up the normal force. All of that did not involve friction at all. Just to be clear, like that was a piece of this whole lab analysis. That was just zooming in and showing you why we think about mg the way we do when we're on an inclined plane, period. So you can't learn anything about the friction detail from that video. That video was all about the mg sine theta detail, or the mg detail, for what it's worth. But then what we're saying is, even when you put friction in here, we're still going to maintain that analysis and that strategy because we're on a track. Because the acceleration is diagonal, we're making a diagonal coordinate system, period. That's number one. Number two, someone said very intelligently in the questions, I mean, in their question, they said, okay, because there's all this component stuff that we're doing. So someone said, I'm getting the theme that, like, you keep saying over and over, Yaverbaum, like you keep saying, like, we treat X and Y independently, which we do. I'm saying one of the forms of Galileo's principle of relativity, one way to say Galileo's principle is every two-dimensional problem is really two one-dimensional problems occurring simultaneously yet independently. In fact, if I'm going to make a big deal of this, I'm going to write that again because it's so huge. Okay. Oh, form. Well, I think this is form five, actually. I mean, it's all one big principle, but I think I call this form five. I think well, okay, sure. I mean, I'll rewrite them all as a list at some point if you want. To me, form three is every velocity is actually a relation between two objects. No velocity is a property of one single object. I don't know if that's what I think form three is, but but what we're saying here is that the X world does not affect the Y world. And someone wrote, right, that's a principle, that's all this vector stuff and all these components. What we're saying is every time we're looking at and it's also true for three dimensions. Every time we look at a complicated situation, if we back up and break it down into a situation and a situation, this situation might well be happening at the same time as this situation, but they're not affecting each other at all. Oh, and this was your question. Yes, person. Oh, right. I think this was your question. Yeah. So the somebody who I might be talking to right now personally, like said, okay, yeah, like you keep saying that, yeah, but I'm like, I see that we're doing that, but I'm actually, the more I think about it, like I'm not really comfortable with that. And this is another great version of a physics question. For someone to say, okay, hold on one second. I don't know if this is a coincidence or not. Hold on one second. I'm just trying. Hold on. Yeah, yeah. You're right. Hey, someone's mic is on. Yeah, yeah, I know, I know. Hold on. Okay, okay. Sorry. Yes. It's slightly ironic because I think it was actually her question, but okay. Um, um, so I thought she was actually trying to say something, but okay. Somebody wrote in the portal, like, I get that we keep taking two-dimensional problems and breaking them down into two one-dimensional problems, and then we solve the one-dimensional problems separately. And yes, that's 100% what we're doing here. Like, again, I did it last week. I'm not redoing it all now. But what we drew all of those diagrams, system schema, pure free body diagram, and then component diagram, so that ultimately we could solve F net equals MA along this axis over here and solve F net equals MA along this axis over here and put the information together. That's the goal of it. Like, that's what we did. That's what's happening. That we are applying Newton's second law to one axis at a time. And we can't do that unless we do all of this diagramming and all of this work to get to the point where we have two separate axes for our analysis. So that is 100% what we're doing. But somebody wrote in the portal, I get that we're doing that. And they basically tacitly said, like, I can do it. But the more I'm doing it, the more I'm like following along, the more I don't believe that. Like, I don't understand like why that's true. Now, again, that's a great physics question to basically be like, all right, I see the math and I can churn the math, but I don't get why the math is like right. And the reason that like I don't get why it actually is true in the physical world, that is totally a good physics question, partly because that's what physicists do. Is we're constantly trying to go back and forth between the math and the physical world, but also for you as a student, it's perfect because what you're really kind of saying to is, all right, I could do this math if you tell me exactly what to do. But then if I get to an exam and it's a new physics question, and now I have to know what math to set up or which equations to choose, if I'm supposed to be thinking about this physically in order to do that, I'm not comfortable with the things that you're saying, with that Yaverbaum is saying about the physical world. Like, I'm not comfortable with this, Matt. That's right. Good for you for noticing. So let me tell you, I mean, of course, like everything, takes getting used to. But the reason we say the X world does not affect the Y world, and it is a surprise. We're surprised by it. That's why it's Galileo's principle. Galileo's a genius. Like, it's why it took 2,000 years to realize this. It's not obvious that the X world doesn't affect the Y world. But the reason it's true, once you really think about it and you really practice and you really look at all the other forms of Galileo's principle of relativity, if you really think about relativity, what we're really saying in the end of the day is X axis and Y axis, that's in our head. X-axis is what we're assigning to reality. There's no actual X-axis in reality. I'm not saying things don't move in reality, but I'm saying like this whole business of saying this is X and this is Y, or tilting our head and saying this is X and that's Y, and that's Y or whatever. Like that's how we're looking at it. What's and how we're looking at it should not change the reality. So put another way, the x-axis is its own mini coordinate system. The what, right? It's the simplest coordinate system there is. It's just a number line. That's why the whole class started with homework one called number line. Why we spent so long on it, even though it seemed really stupid, maybe, or boring at the time, probably was boring. But like, we're trying to say, like, the laws of acceleration, the definitions of acceleration, velocity, all that kind of stuff, that's just about how things move in a line. And the line that we're examining is up to us. All the rules that happen to something moving in a line, like a line is the simplest possible coordinate system or perspective. It's the simplest possible lens through which we can observe and measure motion. So whether we look at it this way or we look at it that way, that's just our lens that we're looking through. It shouldn't matter to reality what lens we choose to look through. The laws of physics should be the same either way. This is what Galileo's saying. So just like you get in an airplane, and it doesn't matter that the airplane's going 500 miles an hour past the Earth, still you can eat your food normally, and you don't have to like eat like this or what, right? Or still, if you drop your wallet while you're sitting on an airplane going 500 miles an hour, the wallet lands on the floor directly below your hand, right? The wallet doesn't care that the plane's going 500 miles an hour because the wallet's also going 500 miles an hour. The laws of physics don't change at different speeds, and they don't change at different perspectives or different coordinate systems. The laws don't change from 500 miles an hour to 0 miles an hour. And similarly, they don't change from the x-axis to the y-axis, because the x-axis and the y-axis are just how we are observing. Wait. Oh, thank you. Okay. So, all right. So cool. So yes, fine. Good. Thank you, Andy, for the feedback. I mean, so yes, in the end of the day, I mean, and again, why I get so excited. All of this stuff like makes sense when I say it, right? I mean, it does, like it makes sense, right? But what's mind-boggling is not that it's true, but that it has so many implications. That these truths, that Galileo's truth, that how one thing moves is a comparison to how something else moves in the end of the day. It has all of these implications and all of these laws and all of these problem solving techniques just come out of that way of thinking. It's one way of thinking, which is why we call it Galileo's principle, form number one, form number two, form number. This is all a way of thinking called physics. The language is math, but the way of thinking is physics. The thing we ultimately care about is space and time. And the thing that we're starting with about space and time is that when an object moves in space and time, its motion is meaningful only in comparison to another object. That's what all of this is about. All right, wait, so it's 12:04. So I was going to do one other thing, but it's fine. I totally didn't. I know this was like one of those kind of classes, but hopefully this was helpful in any way. Hopefully this clarifies the material. And so I think your questions are, if nothing else, it shows like all of this stuff is better when it's coming from you than me. So keep the questions coming. I would never put something on an exam that we didn't talk about in class. By the way, if there's any concern about that, what's on the exams is what we talk about in class, not something that whatever. So this is what we did today. So this is what we did today. All right. So I won't see you Wednesday. So just keep on keeping on. Be patient with me, and I'm patient with you. Just catch up wherever you need to catch up, and have a great holiday. Or text me if we'll set up a phone call to talk. Okay. Have a great holiday, everybody. I'm stopping.